Hello there! Welcome to my masterpiece, the Drought Predictor, a global indexing project built in Python and Jupyter Notebooks. We will be covering all of the events that led me to create this project, an overview of the project itself, and the future that I've envisioned for it. Climate change has become the prominent issue of our time, breaking into the political and even personal sphere of our lives. The problem with climate change is the numerous effects it has on the world, ranging from wildfires to heat waves, to global warming to droughts. This is disrupting the ecosystem and our daily lives, to a point that casualties have occurred. At his second inaugural address, Barack Obama said, "Some may still deny the overwhelming judgment of science, but none can avoid the devastating impact of raging fires and crippling drought and more powerful storms," as an argument for action against climate change. Now, I will delve into the purpose of my project, Drought Predictor. Droughts are dangerous. Due to low levels of water, an essential part of life, the whole food chain is affected at once. This is because all life forms require water regularly. Most work that focuses on predicting areas that are likely to be affected by droughts, to the measurement analysis of indexes such as the Standardized Precipitation Index, SPI, or the Palmer Drought Index, PDI, are usually focused on one nation or a subset of that nation, rather than on a global effort. However, organizations have the data necessary to calculate the likelihood of droughts at locations around the world. For example, NASA's collected precipitation values at a global scale through their Global Precipitation Climatology Project, which is the only information necessary to calculate a Standardized Precipitation Index. Thus, the purpose of my project is to create a Jupyter Notebook to determine where droughts are affecting the world in a readable format, while allowing the scientific community to build and learn from it. The tools and data I've used can be found at these links. The last link is where I've uploaded my project. My GitHub account is toycoder, and a notebook, along with a few CSV files to get started, have been uploaded under repository Drought Predictor. If you want to add more data, you can do so, but you need more files. To do so, go to the second link, choose the year and dataset you want, and download the .nc file. Next, download Panoply from the third link. This is NASA's software to view the data and convert a file to a .csv file. Note that Panoply will require Java 11 or later. Next, I will provide an overview of my project as well as showcasing my Jupyter Notebook. Here are 3 screenshots of my project. Don't be worried about the image in the right corner. That will only occur when you zoom out too far. However, it demonstrates the vast number of locations that were indexed and plotted by my program. On the left, we see 2 images, a close-up of North America and a strip of land containing Alaska and Canada. As the legend indicates, the area is mostly moderately or severely dry. This should raise concern for local and national authorities in these regions. After downloading the data, I studied it using Panoply, which is a built-in map and array viewer. Once I had a feel for the values, I converted the data with Panoply into a CSV file. Using Python, I was able to process the precipitation values for a CSV file into a usable format. Next, I manually hard-coded the SPI index formula, which I found in its original research paper, and ran the precipitation values through it. Thus, I was able to index thousands of points on the globe, from extremely wet to extremely dry and everywhere in between. Because of the sheer amount of values, it would take hours to load the points with a dedicated GPU, and the free ones would not work. Thus, I skipped over a few markers because it still efficiently completes the job, as the crowded map on our screenshots page showed us. Python has a large ecosystem of plugins that allow this project to exist. The CSV module helps programmers read and write to CSV files, which was necessary to interact with the databases by NASA. The IPyWidgets module was especially important because it allows for the addition of interactive widgets in Jupyter Notebooks, such as maps. Because of this, as well as the cell-based format and Markdown support, I use Jupyter Notebooks over Python. Now, it is time for the grand reveal of my project. Welcome to my project, Drought Predictor. This is a Jupyter Notebook that will host the map itself. If you look here, these are all the cells. These are specifically Markdown cells, a text-based format that will allow others to read the text on here. If we scroll down, we will find the actual code. This cell holds the imports. This one will calculate the SPI using precipitation. The precipitation values can be found in the next cell block. These are all the file names that will be used to calculate. Down here, the map will be created, and the map will be called. To see the map, you have to first click Run All. Then, because of thousands of markers that are being calculated and then rendered, this will take quite some time. You can see the time right here. So, in the meantime, let's look at what you should do to add your own files. To add your own files, first add them in a project folder. They should then pop up here. Next, add the file name as such, 2 quotes and a comma, and then the file name.csv. Since we don't need this right now, I will delete it. Now the project should be ready. Let's go all the way back down, and here we go. That is a lot of markers. As you can see, there's a lot of severely dry and moderately dry markers, which is not a good indicator. Luckily, we also see a lot of extremely wet and moderately wet. Now let's see what's happening up here. If we look right here, we can see a huge cluster. And when we zoom in, we can realize that this section is Alaska and Canada. Because it's still rendering, this may take some time. This means that this section needs quite some attention. Now, you probably see these blue markers right here. That is just not loading yet. These are the new normal markers. Since they make it a majority, which is a good thing, then it will take more time to load, and it will load last, as per optimization. And this is my project. Thank you. As you've seen, this project is functional and quite accurate. However, it is far from over. I have a roadmap prepared for its future endeavors. There are 4 pillars to the future of this project: expansion, design, strategy, and launch. Currently, my project only utilizes the SPI index because of its relatively simplistic nature, the ability to determine the rarity of a drought using multiple timescales, and only requiring monthly precipitation values. However, other indexes, such as the Palmer Drought Index, have their own strengths, and together, they will be able to make more accurate conclusions. The map design can also be decluttered and made more versatile for general end users. Finally, I plan to launch the map onto a website so that other people will be able to read this project with ease, rather than downloading a notebook. However, I will have to move from a Jupyter Notebook to a production-ready Python file. Climate change has become an imminent threat to our planet. Together, we can overcome this problem as we have done before. This project will help us find locations that need help for a drought has devastating effects on plant and animal life. Actions that can prevent or battle droughts include harvesting rain, better irrigation, or smart water systems. And this concludes my project. Thank you for having me. You can find this project alongside my many others on my GitHub account, which is @twigcoder. If you have any questions, please feel free to reach out to my email. I hope that you found this as interesting as I did.